everyone, I'm Sarah, and today I'm going to talk about room flows, long network API calls, and how to create a really good user experience. So first, let me just show you around my project here before we get started. I wanted to mention that I am using Android Studio Dolphin. So it's the beta version. I really like it. If you haven't tried it, I really recommend you give it a shot. It's got some great features for Jetpack Compose. For Gradle configuration, I created an empty Compose project with Material 3, and right off the bat I got some compile errors. So I was trying to use the latest version of everything, and I bumped everything up as high as I could. So I've bumped these versions up a little bit, and I'm using Kotlin 1.6.21. And for the module, I'm using capped for room. I bumped up my compiler extension to this beta version here. And I also added some dependencies for room and dependencies for the view model. As for the design and the theme, I just went with something very simple. I didn't use the color KT file at all. I just created the same theme for dark and light, and they're just blacks, whites, and reds. Very simple here, nothing important to see. One thing I did want to mention, if anyone is creating some of the newer Material 3 themes and you're using Android 12 support with the Material U and dynamic colors, in your previews, make sure to pass dynamic color equals false if you actually want to see your theme. It's just a little trick, otherwise you might change a color and wonder why it's not changing because it's using a dynamic theme instead of your defined theme. And I can show you what I'm talking about here in my main activity. So this is a little mock-up here in a preview. I'm using light mode, basically, setting my device and my API level. And this is what I was talking about here. Dynamic color equals false. And this gives me the true colors for the theme that I've defined. In my data layer, I have a really simple city data class. It has a city ID, a city name, state, latitude, and longitude. I also have a city and weather data class, which will combine the city data class with a weather object. And instead of typing out a complete weather object, I'm just using a Boolean value here, which is fine just to demo what I'm trying to accomplish and experiment with different things. Next, I have my city DAO. It's pretty standard stuff here. I'm selecting the count from the city, and I actually use this to pre-populate my database, and I'll show you guys that in a second. I also have an insert all. Again, that's for pre-populating the database. And then insert a single city, and then finally you can get an entire city list from the database. Here's my database class. It's pretty standard except for a few couple things that I added. So basically you have your abstract class to create your database. I've included my city DAO, and here's where I kind of vary from the norm. I know with Room you can just attach a pre-populated database file, and it has built-in methods in the builder where you can just pre-populate everything like that. But I wanted to keep everything in line and just do everything from within my project nice and easy. So for this, I created a little function that populates the initial data. And it basically calls the city DAO and gets the count of the city table. And if the count is 0, then it inserts all of a predefined variable that I've created, which is a predefined list. And let me go ahead and show this to you. So here's my import list, and it's basically a list of cities predefined with the city name, the state, and the latitude and the longitude. So next we go here. And again, this is pretty standard except for one variance. You may see the synchronize keyword here for threading and thread safety. I couldn't use that in my class because after I build the database, I'm populating the initial data here. And what that does, it's a suspend function, and it calls this in a critical section. So in order to avoid that, I had to use a mutex with lock. I'm not sure if that's the best way to do this. I mean, you can have problems with deadlocks and things like that. If anybody has some ideas to do this better, I would love to know. Please let me know in the comments. But basically this creates my database as a singleton, and I'm not using Hilt, so it's just going to create it every time the view model launches. And going back to my list of cities, I also have a separate city list here, so when you click on the Add City button, it'll just loop through this list and add a city, kind of simulating user input, so that way I didn't have to like have a whole screen to let you input a city and look it up and things like that. So next, let me show you my repo here. Again, pretty standard stuff. This current index to insert a city, again, this just goes through, like when you click the add button, it'll insert the first one, and if you click add again, it'll insert the second one, and so forth. This is my simulated weather API call. So basically, what I'm doing, well, I'm not doing anything yet for this first example, but I'm just returning true. And, you know, we've assumed we've gone out to the API, called our weather data, brought it back, and then populated the data class with the object. And finally, I have get all of the cities. So here it goes to the room database, it pulls a city list, and then it maps the city list to the weather data. So basically, I make a call to get weather with my latitude and longitude, and then I combine it for a new object, city and weather, where the city is it, and the weather is the weather that we've returned. Let's go ahead and see what this looks like. I mean, this is really simple. It's just pre-populating the room database, returning the list of cities, mapping it. There's no delay, so this should be super fast and work great. So let me go ahead and rerun it here on my emulator, and boom. I mean, that's great. That's an awesome user experience. But what happens when we hit the network? And I mean, let's say you've got an API that only allows one call per second because you're in trial mode, or maybe your network's just running really slow. Then you're going to have a delay and the home screen isn't going to load as fast. So next, let's take a look and see what that looks like. In my repo, I've created a different branch. It's basically the same as what you see here, only we're adding the delay. So let's see, I believe it's this one. Let me go ahead and check it out. Okay, so let's go to our repo. So now, you know, the same thing, I'm getting the list, the city list from room, and when I populate my weather data class, I'm adding the delay. So let me go back to my emulator here, and let's just stop it and run this. Boom. So that's a terrible user experience. I mean, this is when a user first loads your app, they're going to have this huge wait time, and typically, you know, you'd have some kind of spinner, or maybe you'd have a shimmer, but it takes a while and nobody wants to wait that long for your screen to load. So I was playing around with different ways that I could return this flow and try to at least get the data to the user as quick as possible. So even if it is loading slowly or there's a lot of calculations, the user can have the appearance as if the app is working and it's responding and it's reactive. So next, I'll show you what that looks like. So I've switched branches again, and here we have the same call to get weather with the same delay. But this time, when I actually call the city list from the room database, I'm creating this mutable list here. And now, when I loop through the city list for each of them, I'm getting the weather, and I'm mapping the city data with the weather. But this time, I'm adding the city and weather object to my mutable list, and then I'm emitting it. So effectively, this is just going to emit one city and weather at a time. So let's see what that looks like. And we'll stop this. Give it a run. So here we go. They're coming in one at a time. Not too bad. I mean, the minute I open the program, I see that it's responding, it's working. That's a pretty good user experience, but I still wasn't happy with this. I wanted to do something better, and really I just wanted to try different things. I mean, I tried about 1 million different things. So let me show you my final branch, which I'm really happy with. So I have a new branch loaded again, and this function is doing something very similar to the previous demo, but this time what I'm doing is I'm emitting the whole city list initially. So the whole list that's mapped to a city and weather object. And then I'm looping through the city list again, and I'm getting the weather data, and I'm basically modifying my mutable list each time. So there's an initial list with no weather data, and then the weather data will gradually populate as it loops through each city. So again, let's see what that looks like. So here we go, we have all the cities, and then the weather data comes in as it's collected from the network. And I really like this because it shows you everything on the screen. It's really reactive. Everything's happening pretty quickly, and you can see it. I mean, of course, there's tons of things you could do here. You could add a little spinner on the right-hand side as it's loading the temperature data. You could have a shimmer. But basically, when users log in and you make that initial call, and nothing's cached yet, so you have to go to the network. This way they'll have just a really good experience, and they won't go to the next weather app because there's a million of them. So these are my little experiments. I'm not sure if I'm doing it the right way or not, but they seem to work really well. They still follow clean architecture patterns. So if you want to check it out, I've put the link in my GitHub repo, and I would love to hear comments, or if you guys have any additional ideas to make this even better, or if there's more efficient ways to do it, I'd love to know. Thanks for watching. Bye.